Hello everyone, this is Shivsai Reddy. Welcome to my channel on science, technology, environment and climate change, where we will be discussing various advancements in the field of science and environment that are helpful for the UPSC preparation. Today we will be talking about the topic space sustainability. So broadly, this topic comes under uh, this topic is relevant in case of both prelims and mains, given that space technology is a part of syllabus in both prelims and mains examination. So it comes under science and technology, particularly the space technology. And in the space technology, this belongs to space sustainability. I believe that this topic is very relevant and important in coming years because recently the space organizations across the world, including ISRO, NASA, ESA, and many others, are focusing on space sustainability. And coming to the first part, what is the need for space sustainability? So we all know that there is increasing space junk as more and more space missions are being undertaken. We have the payload leftovers, we have the dead satellites which are currently roaming around the planet at a very tremendous speeds. We all know the Kessler Syndrome, where there is this chain reaction of one space debris creating few more debris. Ultimately, there is a threat that we may reach to a point where all these space debris will prevent us from carrying out future space missions because of the safety aspect. So, presently, there are 10,000 active satellites, and the number is projected to reach up to 1 lakh by 2030 and possibly half a million. So, just imagine half a million space objects, and after their service time is over, they become space junk, and each payload may further divide into many small pieces. And if you all imagine that our entire Earth will be surrounded by such small pieces, and it will make almost impossible to carry out future space missions. And apart from that, we also have the threat of air pollution. What happens is that as the satellite reaches the end of their life cycle, some of them will stay in space as a debris, and some of them will re-entry into Earth's atmosphere. And in this process, they usually burn and they release very harmful pollutants such as aluminium, nitrogen oxide, black carbon, etc., which contribute to atmospheric aerosols. And we all know the role of atmospheric aerosols in causing global warming, climate change, etc. One more aspect is that the emissions from satellite re-entries will lead to depletion of ozone layers because rocket launchers will release chlorinated gases, carbon monoxide, and some other pollutants. And in these pollutants, one of the important pollutant that you need to remember is aluminum oxide, and it possesses a very serious threat to ozone layer. And apart from that, we also have metals. All the spacecrafts are made up of various metals, and as they burn, they release metals and metal oxides, which absorb the solar energy and causes global warming. So, in light of all these issues and concerns, uh, space organizations today are focusing on space sustainability. Apart from these concerns, we also have our SDG goals, our commitments to UNFCCC, etc., which uh, makes us to focus on the space sustainability. Coming to the facets of space sustainability, here I'll discuss various dimensions on how India and other countries are paving their paths towards space sustainability. The first important aspect is using green propellants. So we all know that the launch vehicles uses fuel and oxidizers as a propellant, which drives them into space. And conventionally, we have PSLVs, the India's launch vehicles, GSLV, which have solid engine, liquid engine, cryogenic, semi-cryogenic, and each of these stages uses a different kind of fuel and oxidizer. And one of the most important such fuel is hydrazine-based fuels. In case of India, in the liquid engine, we usually use hydrazine as a fuel, and these fuels are highly toxic and leaves reactive byproducts, which are a concern in the atmosphere. So currently, there is a focus on green propellants, which may have comparatively less polluting capacity, and they're also comparatively greener throughout their life cycle. One such important green propellant is hydroxyl ammonium nitrate, or in the shortcut we call it HAM. ISRO, NASA, and many other space organizations are working on replacing these conventional fuels with this green propellant. And recently ISRO has fired indigenously developed thruster using ammonium dinitramide as a fuel. So this is the right time for you to revise what are the fuels for each stage of rockets and what are its oxidizers. At the same time, remember the name of these two green propellants. And coming to the next aspect, use of sustainable materials. Why do we need to use sustainable materials? One, to reduce the space junk, to promote circular economy, and also to reduce aluminum oxide generation, which we have discussed above. And a very recent innovation was carried out by Japan. That is, in November last year, they have launched LignoSat. And what makes this satellite so special, excuse me, is that it is made up of wood, Mongolia wood, and replacing conventional metals with wood will ultimately makes it sustainable, because number one, wood will not leave harmful residues as compared to other metals, and ultimately the production cycle of wood is more sustainable. So this is very important. Just remember for this. So this paves way for future eco-friendly satellite technologies, wood-based innovations, which has potential applications in future space missions. Also, in these lines, even Indian institutions, especially ISRO, is evaluating natural fiber composite panels, for its future satellites, which is under sustainable materials. And coming to the next aspect, reusable launch systems. And why this become important is that today the rockets that we use, especially the PSLV, GSLV, and other countries' rockets, they are mostly single-use rockets. So once they carries out their purpose, we have so much wastage and also so much space junk. So what countries are doing in this aspect is replacing the conventional launch vehicles with reusable launch systems. Particularly, ISRO's Pushpak RLV is India's innovation in this aspect. So what happens is that here we have the RLV. This goes into the orbit and then it launches satellite, and then for further it comes back. It lands as shown in the picture. So by ensuring this, we are reducing the costs, we are reducing the wastage of materials, reducing space junk, ultimately promoting circular economy or in the space missions. At the same time, we also have ISRO's POEM. So POEM stands for Payload Orbital Experimental Module. So what is this about is that we all know that PSLV has 4 stages. So the fourth stage particularly, earlier its purpose was simply just to launch the satellite into the designated orbit, and it will exhaust itself, and it remains a space junk. So what ISRO did was that it changed this spent 4 stage into an orbital experimental module. So instead of just being a space junk, it is acting as a platform for carrying out scientific experiments. Instead of just being a space junk, it is fitted with different payloads to carry out various experiments. So by doing this, we are promoting more use efficiency for this stage. And in the same lines, even the private sector in India are carrying out many innovations. Let's say that, for example, the Skyroot private firm is developing 3D printed rocket, which cuts the emissions compared to the kerosene stages. Since it is 3D printed, there will be less wastage of materials, and also it reduces the cost. Likewise, we also have Agnikul's single-piece engine, and yeah, we also have SpaceX Falcon 9 engine, which is globally well known for its, I think most of us have seen these videos where a part of launch systems will automatically come and land back into the launch pad. So in this way, reusable launch systems is one of the aspects of space sustainability. And final aspect of this is that debris-free missions. In this, we have ISRO's IS4OM, NETRA, which or a network of sensors for space debris management. And here the most important thing which you need to remember is the debris-free space mission pledge. ISRO committed this pledge in April 2024. Basically, ISRO, what it commits is that all the Indian operators, whether being government or private, they have to ensure that they leave zero debris on orbit by 2030, either through controlled re-entry or stable graveyard disposal. So their purpose is to not add anything new to the space debris from 2030. And one more aspect of this is that passive deorbit add-ons. So basically what this means is that let's say that there is a spent rocket stage, or else any satellite which has reached its purpose or end of life cycle. Then what happens is that it is being fitted with some payloads which helps it to come back to the orbit and safely dispose into oceans or somewhere. So by ensuring this, we are reducing space junk. So yes. So these are the 4 aspects of space sustainability that I couldn't think of, and what ISRO did in these aspects, along with some global examples. If you come across, or if you feel that there is any new dimension for space sustainability, please let me know in the comment. And this is a MCQ based on all the above. Just try to solve the answer, and please comment the answer in the comment section. And with this, we come to an end to this session. Thank you very much. Finally, I just wanted to tell you that climate change is real. We need sustainability everywhere. We need sustainability in space, we need sustainability in our lifestyles, everywhere in order to save this planet. Thank you.